Alright, so we keep going. We're going to keep checking the next section of the SCD math test. This is test number, I don't know, test number 6. Yeah, and this is still section 3. So we have just finished to question number 11, and we just keep going from 12 to 17, I hope. So, okay, so 12, we have a point on the trigonometric circle. So we need to ask about us about the relationship between the value of the angle in radian with the coordinate of the point on the trigonometric circle. So let's draw it out. See, okay, so we have let's center it a little bit so it looks symmetric. Right about here. Okay, so we have a point A here. Right? And the coordinates is just m n as according to the uh, exercises, or as I just draw it, I stated it a little bit, and that's just an arbitrary number angle alpha. So this is the point AMN, right? All right. So now we're gonna care about this angle alpha for now. We can care about this angle. Let's say alpha. I'm just gonna do this symbol on my computer because I don't have that symbol on the notebook on the pen. So let's call the coordinate O, and we just draw a perpendicular line from A to the OX axis. This is the OX axis, and this is a perpendicular line. And we're gonna set this point to, let's say M, let's say B. Okay. So so you can clearly see that OA is equal to 1 because this is the unit circle. So because this is unit circle, so here's 1. So it has radius of 1, and this is the unit circle. So we know that the side of the right angle triangle is gonna be equal to the hypotenuse times the sine function of the opposing angle. So it's a sine is equal to hypotenuse sin times sine of opposite angle. And we know also though that the sine gonna be hypotenuse times cosine of adjacent angle. So in this case, we can see that the side M gonna be equal to so the hypotenuse is just OA times sine, because okay, so the M is just OB, right? M is just OB. So it's always OB is gonna be the hypotenuse times cosine, because OB and OA are just the adjacent relationship cos of alpha. So and we have n gonna be very similar, and and so the sine of n is actually AB gonna be OA times sine of theta, because it's the opposite side. So OA here we have just denoted is 1, right? So okay, OA is not 1, OA is actually 5, right? OA is actually 5, so 5 times cos theta alpha, and here is just 5 times sine of alpha. So So you can see here they ask about n, right? So n is 5 times psi of alpha. So the answer for this is a. So OA here is not 1 because in my case it's 1, but this is actually 5. This is actually 5, right? And this is could be a 5 as well. Doesn't matter. Actually, as long as this is a circle, that's whatever. So this is magnitude 5 here, but it's all the same. All the same. Yeah. Okay, so number 13. Let's go. Let's come to number 13. So number 13, what do we have here? Uh, okay, so we just have to simplify this thing. So that's quite normal. X plus 1. Just x plus 1. Over x minus 2, x plus 2, alright? So minus x minus 2 over x minus 1. So we're gonna get the two denominator to be multiplied with the common denominator, right? So this is gonna be given something like say over. So in the denominator, gonna be x plus 2 times x minus 1. So that's the common denominator, and in the numerator we just have the fixes, right? X plus 1 times x minus 1, which is the odd denominator, x minus 1, and we have to minus for what it is, x minus 2 plus x plus 2, x plus 2, all right? So this gonna turn like we keep the denominator the same. So on the top we're gonna have here is something like x squared minus 1, and this gonna be minus 2 x squared minus 4, because we have this formula of uh, uh, a plus b times a minus b can be reduced to a squared minus b squared. So we're gonna apply this formula. Uh, so we just cancel x squared here. So it's gonna be 5 on the numerator. So it's equal to 5 on the numerator. And for the denominator, we just keep everything the same. So the answer for this should be, oh, there was something wrong here. I don't know. I wonder what it is. No, this is 4. 4 minus 1, so it's 3. Sorry, 4 minus 1, so it's 3. Very 3, 3. Yeah, sorry. So because we have a minus 4 is plus 4 here, and minus 1, so it's 3. It's a positive 3, right? Sorry. Was a, a big surprise. Yeah. So 3 over x plus 2 over x minus 1. So the answer for 13 is C. All right, C. Okay. Okay, let's move on to question number 14. We have some I here. So here, what you should do is very simple. So all you have to do is just you know that I squared equal to -1, and you just do the normal like arithmetic with a fraction like you have learned. So 4 plus I over, I just say over like this, whatever, over. Okay, so over later over 1 minus I. Okay, and all this is plus with what it is, 2 minus I over 1 plus I. So we do the same thing as we did before. We just find a common denominator, and we just do it. And wherever we meet with I square, we're gonna replace this with minus 1. Okay, we're just gonna replace this with minus 1. So with this is gonna be equal to, okay, so we're gonna multiply on this side everything with 1 plus I. So 4 plus I times 1 plus I, and plus 2 minus I times 1 minus I over 1 minus I times 1 plus I. Okay, so now we're going to just apply the same formula here. A squared plus b squared, a squared minus b squared just equal to a plus b times a minus b. Just gonna apply this over. So just apply this over. So here what we have is that, okay, so on the uh, so on the numerator we just have to do expansion, right? Just have to do the expansion, and the denominator we can apply the formula. By us on the numerator we just have to expand. So 4 plus 1 times I is just I, 4 times I is just 4I, and I square, right? I square. Okay, so plus, okay, 2 times 1 is 2, minus I times 1 is minus I, 2 times minus I is minus I again, and minus I times minus I is just I square, right? Alright, so that's the numerator, and here's the denominator. Uh, okay, so a minus b times a plus b, so it's just 1 square. Minus I square. Okay, okay. Now I think we are ready for the reduction, but we should keep a key formula in mind that wherever with I square we can replace this with minus 1. Okay, so this is gonna reduce to, okay, so equal to what it is. So I square is negative 1, so 4 minus 1 and 1. So I plus 4I is just plus 5I. So 4 minus 1 is just 3, alright? So 4 minus 1 is just 3. Okay, here, what it is? Minus I is minus 2I, and I square is negative 1. So 2 minus 1 is just 2 minus 1 is just 1. Okay, so this is going to be over 1 square is 1. I square is just negative 1. So 1 minus minus 1, like this. Okay. And this is going to be reduced to okay, so on the numerator now we have 3 plus 1, that's 4. 5 minus 2, 5I minus 2I, so that's plus 3I, and O over 1 minus 1 is just 2. Over here I think it makes some error somewhere, like is this kind of odd? This is kind of odd, like the answer is kind of odd. I think I make some a mistake somewhere. It should be 2I here, but I was making some mistake somewhere. Let's see. Okay, so cross multiplication, plus 4I plus I squared minus I. Oh, yes, minus 2I here. Sorry. It's minus 2I here. So I was miscalculating on this side. So so okay, let's calculate this again. So 2 times 1 is 2. Minus 1 times I, minus I times 1 is minus I. 2 times minus I is minus 2I, and minus I squared times minus I is just I squared. Okay, all right. So here is minus 3I. Sorry, minus 3I. Yeah, that's correct. So this is gonna come to something like okay, so 2 and minus 1, so 1 minus 3I. So 5 minus 3 is actually 2I here, right? 2I here. 3 plus 1 is 4, 5 minus 3 is 2, so 2I here. So with that, we can reduce this fraction into 2 plus I, because you just multiply both things for 2, so that's equal to 2 plus I. Okay, so with this, the answer for number 14 should be B. Okay. All right. Let's check if we are correct, because I kind of have to go now. So let's check if we are all correct. Let's see. So we check number 13 and number 12. So number 12 is A, which is correct. Number 13 we denounce is C, which is correct. And number 14 we have is as B here, which is also correct. So that's it. That's it for today. Thank you very much. Have a good day. Thank you.